Exercise 11.2. The first question. You are given a direction cosines of a line. Let me call that as L, M and N. These three direction cosines you are given. You are asked to show that these are mutually perpendicular. So what we need to show? Perpendicular means the dot product equals to what? 0. So we show that if I take any two out of these three, then the dot product is 0. So we need to show this. What we need to show? If you find L dot M, it must be 0. M dot N, it must be 0. And if I do L dot N, that is also 0. These three dot products must be 0. That's what I need to show. So you know definition of dot product very well. So I'll do L dot M. So what is that? This into this, which is minus 48 by 169. This into this, actually you have plus between these two. So this is minus 36, this into this by 169, plus this is nothing but the minus 12 by 169. Now here you can see that, sorry, this is my mistake, this is plus in the given question. So this is nothing but the plus 48. So this will be, you can see that it will be 0. Same way, if I do M dot N, then this is 12 by 169. This is nothing but the plus here, minus 48 by 169, plus here this is 36 by 169. This into this equals to again 0, you can just see. And if you do L dot N, you can see that this is also 0. So this L dot M equals to 0 means L and M are perpendicular, M and N are perpendicular, N and L are perpendicular. Therefore you can say that direction cosines are mutually perpendicular. Direction cosines are mutually perpendicular. That's what you wanted to prove. Fine, that's the first question. Now let's see second question here. Question number 2 says that the line through these 2 points, so let's take these 2 points as A and B. So A is this 1 minus 1 2, and B is this 3 4 minus 2, is perpendicular to line through these 2 points. So let me call that as C 0 3 2, and D as let's take 3 5 6. So it's like this. You have one line that passes through these 2 fixed points. So for example, this is direction of this line L, and you have one more line like this, maybe anywhere, remember here, like this. This is another line that passes through these 2 points C and D, and you want to show that they are perpendicular. So what we do, we show that these two vectors, vector CD and vector AB, are perpendicular. That's sufficient, right? So therefore here we'll find the vector parallel to direction of this line, that is vector AB. How do we get this? B minus A. So 3 minus 1, which is 2 here, comma 4 plus 1, which is 5, comma minus 4, and vector CD, that is 3 minus 0, which is 3, 5 minus 3, which is 2, and 6 minus 2, which is 4. So this is the direction of the line L. Let me call this another line M. So CD is direction of the line M. So therefore, if I get the dot product AB dot CD, let me find this here. So here dot product will be 6, 2 into 3 plus 5 into 10 minus this into this, which is 16. So you can see that it is 0. So dot product of the directions of these two lines is 0. So therefore, what is your conclusion? Therefore, you can say that lines are perpendicular. Lines are perpendicular. That's what you wanted to show. Fine. Lines are perpendicular. So in the next question, you need to show that the lines are here parallel. So I'll take again 2 points. One is A of 4, 7, 8 and B as 2, 3, 4. Let's take C as -1, -2, 1 and D as 1, 2, 5. Right? So you have one line like this that passes through these 2 points A and B. The other line like this that passes through C and D. So this line through these 2 points, the other line through these 2 points are parallel. So you need to show that these direction vectors are multiples. So let's find the direction vector AB here, which is 2 minus 4 minus 2, 3 minus 7 minus 4, 4 minus 8 minus 4, and the direction vector of the other line CD, 1 minus 1, 1, which is 2, 2 plus 2, which is 4, and 5 minus 1, which is 4. So clearly you can see that here AB equals to some scalar lambda into CD. Where lambda you can see very easily. If I multiply this with -1, you will get this. So -1, which is a real number. It can be any number, that's not important, remember. So direction vectors are multiples of one another. Therefore, what's the conclusion here? That these two lines are parallel. Therefore, lines are parallel. That's what the important conclusion. The lines were perpendicular, your lines are parallel. Okay, now next question, question number 4, fourth question. What it says, the question number 4, find the equation of the line passing through the point 1, 2, 3 and is parallel to this vector. So you want to get the equation of the line. So let me write just here to remind you. We find the vector form the line here, which is R equals to the fixed point is vector A plus lambda into the direction of this line. Well, lambda is a scalar, you know. This is what you want to write here, vector form of a line, remember. So here in this case, what's the fixed point? You are given vector A, that's a fixed point. Line passes through which fixed point? 1, 2, 3. Right? So if you want, you can write I cap plus 2j cap plus 3k cap. And the fixed point, which fixed point? Direction of the line. It's parallel to this vector. So 3i cap plus 2j cap minus 2k cap. Now we just place these two values there. So therefore the required line here, the required line which is in the vector form, vector R equals to first fixed point I cap plus 2j cap plus 3k cap plus scalar into the direction of the line, which is 3i cap plus 2j cap minus 2k cap, where lambda is a scalar, so lambda belongs to R. That's what the required form. Right? When nothing is given, you can just put into the vector form. If you want the Cartesian form here, let me write Cartesian equation. If I write Cartesian equation here, What's that? Can you recall? X minus x1, fixed point, that is 1, upon first component of the direction, which is 3. Y minus y1, what is y1? 2, upon the direction of the other one, which is 2, equals to z minus z1, which is 3, upon the direction, that's the third component, which is here, minus 2. This is just a Cartesian form. You can write in this form, remember. Which form I've used? X minus x1 upon a, small a, equals to y minus y1 upon small b equals to z minus z1 upon small c. This is the Cartesian form of the line. This is the vector form of the line. The next question, what we want? We want the line in vector as well as in the Cartesian form that passes through the position vector this. So this is a fixed vector, remember, through which the line passes, which is 2y cap minus j cap plus 4k cap. And its direction, that is the vector b, that's the direction vector, which is given by I cap plus 2j cap minus k cap. This is nothing but what? The direction of the line that's given to you. Direction of the line. Now first, vector form of the line. So your vector form of the line that's given by, what's a vector form? Just recall, the vector form is given by vector r equals to vector a plus lambda vector b, where lambda is a scalar. Now we just place the value here. So vector r equals to, what is a? That is nothing but the 2i cap minus j cap plus 4k cap plus lambda. What about vector b, which is I cap plus 2j cap minus k cap, where lambda is a scalar. That much only you need to do. So this is the vector form of the line. Now here you are also asked Cartesian form. So Cartesian form of the line. Cartesian form of the line. Let me just write that form. X minus x1 by a equals to y minus y1 by b equals to z minus z1 by c. What is x1, y1, z1? These are the components of fixed point. What are the components here? 2, minus 1, 4. So x minus x1. What's x1? You can see, which is 2 here, equals to y minus y1. What is y1? That's minus 1. So this will be plus 1. Equals to z minus z1. What's that? That's 4. Upon a, b, c are components of the directions, which is 1, 2, minus 1. So here I have 1, here I have 2, and here I have minus 1. This is the Cartesian form of the line through the given fixed point and having direction as I cap plus 2j cap minus k cap. In the next question, find the Cartesian form of the line. So whenever you are asked equation of a line, you need to ask for two things to yourself. Number one, fixed point on the line. So which fixed point on the line you are given? You can see that is vector a, which is minus 2, 4, minus 5. So which I can write minus 2i cap plus 4j cap minus 5k cap. This is given to you. And the required line is parallel to given line, parallel to line. Which line you are given? You are given x plus 3 by 3. Here's some expression by 5. And z plus 8 by 6, parallel to x plus 3 by 3, y minus 4 by 5, and z plus 8 by 6. So this is the direction of the given line. Now here it's like this, remember. For example, this is our required line and this is a given line. They are parallel, remember. This is a given line, that is this given line. Okay, so direction of this line is known to you. What's the direction of this line? Your direction of this line, that is here 3, 5, 6. You can see 3, 5, 6 components of this one. So being parallel, the same vector represent the direction of the required line here. Okay, so I'll write here direction of the required line, direction of the required line, let me call that as vector B, which is same as the direction of the given line. So which is 3, 5, 6, and which I can rewrite as 3i cap plus 5j cap plus 6k cap. I hope this is clear to you. Just only concept of the parallel lines we have used. This is your required line, this is the given line. You know direction of the given line, which is here 3, 5, 6. This is the direction of the given line. Being parallel, the same vector represents the direction of this line. So what's the direction vector? This one. So now you have direction vector, you have fixed point here, so you can get the equation of the line as I did in the previous question. Now you write the vector form, that is this one, as we did in the previous question. You just write this and you write this Cartesian form. This both the things you can do, right? In any question of getting equation of a line, you need to do fixed point on the line, which I did here. So fixed point is this, right, which is given to you. And using the concept of the parallel lines, I have got the direction vector. What's the direction vector here? 3, 5, 6. So you have direction vector, that's vector B, as like previous question, and you have fixed point. Now you just write this vector form and you write this form. So we'll get the required solution. In the next question, you are given a line in Cartesian form and you are asked to find its vector form. So what you can do is, you can write the fixed point here. So I'll write here the vector A, that's a fixed point on the line, which is given by here x minus x1, so 5, y minus y1, so it has to be minus 4, and this is 6. So 5i cap minus 4j cap plus 6k cap. I repeat, which form I've used? X minus x1, y minus y1. So here you must have minus 4, remember, and z minus z1, so this is 6. You must have minus sign, so that's why this should be minus 4. And what's the direction of the line? The direction, which is vector B, usually we denote, which is given by here 3, 7, 2. These 3 components. Fine. So therefore vector form, if I write vector form of the line here, vector R equals to vector A plus lambda vector B, where lambda is a scalar, remember. So therefore vector R equals to, what's vector A? That's nothing but the 5i cap minus 4j cap plus 6k cap plus scalar lambda. Your lambda, that scalar, what's that scalar? 3i cap plus 7j cap plus 2k cap, where lambda belongs to R. So that's vector form. The next 8th question, you want the vector and the Cartesian form of the line through these 2 points. Your line passes through these 2 points. Which 2 points? One is origin. So here one fixed point is this 0 0 0, that's origin, null vector. And the other fixed point, let me take here vector a1, which is given by here 5 minus 2 and 3, right? So one fixed point, you can use this. The first question, which two things you need? One is fixed point, you can use this. And how do we get the direction? If you remember the theory, direction vector will be what? You can write, let me call this as b, sorry. So here direction is this vector ab, which is b minus a. So what we'll get here? 5 minus 2 and 3 again. 5 minus 0, minus 2 comma 0 and 3 comma 0. This is the direction vector, remember, right? It's like this. If you remember theory, one fixed point is origin, that's 0 0 0, a here, I've called this as a. The other fixed point is b here. So this is the direction of the line, vector AB, remember. This represents the direction. So now you have direction, your fixed point. So you can write both the forms as we did earlier. So let me write here the vector form of the line, that is vector r equals to that fixed point plus scalar into the direction of the line. So vector r equals to, this is null vector as you know, scalar lambda into that vector b. What's that vector b? That is this one. So I can write 5 cap minus 2 cap plus 3 cap. That's the vector form. Fine. Now I'll write Cartesian form. Cartesian form you know very well. So here the Cartesian form will be, what's the Cartesian form? X minus x1, which is 0, upon direction vector, which is 5. Y minus here again 0 upon the second component, which is minus 2, and z minus 0 upon the third component, which is 3. This is nothing but which form? Cartesian form. And this represent vector form, where lambda is a scalar, lambda is a real number. Okay. The ninth question, it's like previous question only. There you have two fixed point on the line. This is a line that passes through two fixed point. One is vector a, which is given by 3 minus 2 minus 5. And the other one is, let me call the b of vector a1, which is given by 3 minus 2 and 6. This is required line L. So one fixed point you can take as this. You know you need the fixed point and the direction of the line. So this is the fixed point. What's the direction of the line here? Direction of the line, that is vector AB, as we did number of times earlier. So which is equals to, what is that? B minus A, you know. So 3 minus 3, which is 0 here. 3 minus 3, 0. Minus 2, so it becomes plus 2, so 0. And this is 11. This is the direction of the line. So 0 I cap plus 0 j cap plus 11 k cap. That's the direction. So you have a direction, you have a fixed point here. So we'll get both the forms. So first, vector form of the line. Vector form of the line. Let me write the equation. Vector r equals to fixed point plus scalar into the direction of the line, where lambda is a scalar. Okay. So this is a variable vector as it is. Fixed point, you know, it is nothing but, which is a fixed point here, this one. So 3 cap minus 2 j cap minus 5 k cap plus lambda to fixed point. What is that? 11 k cap. That's one thing. Now Cartesian form of the line, or Cartesian equation. You know x minus x1, I'm just reminding you, upon one component, y minus y1 upon second component, z minus z1 upon third component. So x minus x1, what's x1? That's the same, fixed. 3 upon here first component, you know it is 0. Right? Here 0 does not mean it is undefined, remember. This is a standard way of writing. Y minus y1, that's minus 2, so it becomes plus 2 upon 0, second component. Z minus z1, what's the z1? That's plus 5 upon c. What is c here? C is 11. This is a Cartesian form, right? Here normally we never write upon 0 in number system, but in vectors, especially in Cartesian form of the line, when you have upon 0, that means this represent the direction component of the given line. So this is a standard way of expressing the line in the Cartesian form, remember.